Hello and welcome to the Ready4 GMAT class. This is the very first class of the best GMAT preparation class of your life. I promise you that. It's a low bar, but I promise this is the most fun you are ever going to have studying for any test you've ever studied for. I know that because I have been tutoring with Ready4 for about a year and other services for about 8 years, and this is the most fun I have in my life. My name is Eric Maltzer. I am your guide for this journey. I am delighted to see you, Jordan, Obiora, and Sarah. Welcome. We have a very small class together, which means that with your permission, I would like to unmute you so that we actually have a live discussion and you can ask questions whenever you want, as opposed to me just lecturing at you. So if you can go ahead and find the chat box, the lower right-hand corner of your panel, and just type in unmute, and I will take that as permission from you to unmute you, and then I will introduce myself a little bit more and get to know you personally. So, all right. Hello, Obiora. Did you pronounce it Obiora?
Yeah, that's close enough, Eric. Or just Obi for short.
Obi. All right. We got Obi on the line, and we have. Let's try. Hello, Jordan.
Hello. How are you?
Good. And Sarah has not yet given permission, so we'll leave her unmuted until she gets. But Jordan, where are you calling in from?
So I'm calling in from Provo, Utah.
All right. One of my favorite states, Utah. Fantastic. Great to have someone in the Western region. I am coming to you from Los Angeles. Obi, where are you right now?
In Los Angeles as well. I just
All
moved
right.
Texas,
Where'd you move from?
3 weeks ago from Houston.
Wow, congrats.
Thanks.
Similarly sprawling, but slightly better weather out here, right?
Agreed.
Yeah, good. Well, Sarah, I don't know if you're there, but either type in or let me know where you're from. I'd love to know a little bit more about you as well. I just moved to LA from New York a couple months ago. I was in New York for 3 years, Boston for 2 years before that, DC for 5 years before that, Boston before that, New Haven before that. So a little bit about me and my test prep credentials. So test prep is the most fun I have in my entire life. I have done a lot of other things, which I'll get to, but I've taken the SAT, the PSAT, the SAT, the ACT, 4 SAT2s, 7 APs, the GRE, the LSAT, the GMAT 4 times, Foreign Service Officer exam, the CFA, a bunch of other tests I've forgotten. 99th percentile on every test, and GMAT is obviously my favorite test, 770, 770, 780, 780. It is a thrill to do it. I love teaching it. I've had more than 1,000 students, and the vast majority get in the top 15%, and almost everybody, sorry, the vast majority score in the top decile, and almost everybody, everyone except for about, I think I'm up to 38 people out of 1,000 have scored. 38 have not scored in the top 15%. So if you're with me, I have high expectations, and I fully expect you to end up in the high 600s or 700s, no matter where you're starting. I've taught people who have started in the 300s, and I have taught lots of people starting in the upper 400s. Doesn't matter.
That is comforting.
So, what's that?
I said, that's very comforting, because the first time I took it, I'm just thinking, oh man.
It doesn't matter where you start. Once you know what I know about the test, it'll be very easy. So I just want to say hello to Sarah.
Hi.
Hey, where are you calling in from or logging in from?
I'm calling from Ithaca, New York.
Wow, Ithaca.
That's right.
Definitely one of my one of the top 8 homes to an Ivy League institution.
That's right.
There are only. But no, I had a really good friend go to Ithaca, go to Cornell Business School. She loves it up there. So you are. That's what Californians. I wouldn't be a real Californian if I didn't patronize somebody in a cold weather place at least once. So Sarah, I've done that now.
You're done right now? What?
What's that?
I said, you're done right now? What?
Well, I'm delighted to have you all here. I know some of you joined just today, I think, but whenever you signed up for this course, I promise you will not regret it. This is going to be a lot of fun. You're going to get all of your questions answered, and by the end of the course, you feel completely prepared to take this test. So let me tell you a little bit, let's do a little ground rules. Let me tell you what I am going to teach and what I'm not going to teach. So what I am going to teach, I'm going to teach you every single type of content that's on the GMAT. You're going to do every kind of math, every kind of verbal. We're going to do the integrated reasoning. We're going to do the essay. And we are going to handle almost every subcategory of problem that exists on the GMAT. What I am not going to teach, I'm not going to teach a lot of formulas. I'm not going to teach a lot of hyper-specific knowledge. I'm not going to teach you things that that show off how smart I am and confuse you. I'm going to teach in plain English. I'm going to teach you in conversational, a very conversational style. I hope you will ask me questions as your questions come up, and we're gonna have a good time. So a little bit, I promised you background about me. I grew up in Tampa, Florida. Go all Tampa sports teams. I went to Yale for undergrad. I worked at the Pentagon for a while. I went to Harvard for grad school. Started a business, sold it. Worked on a campaign. I lived in DC for 4 years. Worked at the State Department, MIT for business school, and have had my own business since then. So I've done some other things too. I lived in Dubai for a while, lived in Spain, England, but that's the basics. But all that to say, that is my favorite thing to do. So we have one more person that just joined us. I'm going to unmute this person. Hello, Alexis.
Hi.
How are you?
Good.
Hi, Alexis. Good. So I just introduced myself. My name is Eric Maltzer. I am your teacher, tutor, professor for the course. This is going to be a lot of fun. It's going to be interactive. You do not have to speak if you don't want to, but I encourage you. We have a very small class. Ask questions whenever you like. Where are you dialing in from, logging in from?
New Jersey.
New Jersey. Where in New Jersey?
Piscataway, Central Jersey.
All right. Well, and do you go by Alexis? Do you go by Alex? How do you like to be called?
Usually Alex.
Okay. All right. So we have Alex, we have Jordan, we have Obi, and we have Sarah. 2 East Coast, 2 West Coast. Jordan, can I call you West Coast? You're like the Western.
Yeah, I'm hard to offend, so you're good.
Those Utahns, they're so nice. All right, so great to have you all here. Before we get started, let me just go around to the 4 of you and let me take a couple notes about what 1 or 2 things you want to be sure to get out of the course, other than like general GMAT knowledge and a great score. What do you really hope to learn? Let's just start with that. So why don't we start with Jordan? Jordan, what are the 1 or 2 things you hope to get out of the course?
The first thing that I would like to get out of the course is really a strategic understanding of how to approach different questions and what's the quickest way to solve them. One thing that I struggled with the most on the GMAT was just allocating time correctly to each question. So, I mean, eventually I got to the point where I was guessing on questions that were very easy, which affected me negatively. So I just want to be able to learn about, be able to understand the quickest way to approach those, as well as just how to manage that time better, I guess.
Okay, great. Strategic approach, definitely. Different questions require different approaches. In general, approaching a GMAT question is a lot like approaching a golf shot. So I don't know how many of you have played golf or ever seen anybody play golf, but basically you're allowed to carry 13 clubs in your bag, and when you first walk up to your job is to hit the ball hard and as far as you can, but in a certain direction, try to get it in the hole. In different, depending on where your ball is, if it's in like deep grass, or if it's in a sand pit, or if it's in in the fairway or on the tee, you use a different club. And on the GMAT, depending on what the test presents you, you're going to pull out different tools. So sometimes you're going to choose numbers, you're going to pick numbers, sometimes you're going to look at the answer choices, but no matter what you do, you're going to, first things first, you take a look at where your ball is positioned and get a sense of what would be best in that situation. So first thing you do when you see a GMAT question, get a sense of what the question is asking and try to determine what the question is really asking in plain English. Okay, if you don't understand the question, make sense?
Yes, that makes sense. Thank you.
But we'll do lots more about this. Obi, tell me, what's the one or two things do you hope to get from the course?
Yeah, similarly to Jordan, I want to learn more about strategy and managing my time a lot better. Like I wasn't able to finish the the integrated reasoning on one of the practice tests I took. And just 3 questions I just had to pretty much guess on. And mostly, like, my weakness is quant, especially the sufficiency part. Like those having to go down those list of 5 kind of boggles my mind at times, and I usually sink a lot of time into those questions and don't really get anywhere with them. So coming up with a better strategy for me for that, those would be my main thing.
Great. Well, data sufficiency, a very idiosyncratic kind of question. You'll never see it again anywhere else in your life. But the skill you learn to solve a data sufficiency question, very similar to what you will do in business school. So in business school, they'll say, well, what extra information would it be good to know from which vice president to make a decision about whether or not you should open a new factory or fire these workers or whatever. You need to know when you need extra information and from where. So being really good at data sufficiency will also make you very good at the case study method. So there's a certain way to approach it that will make you better and better. We will cover that in the course. As far as time management goes, remember, this is not a test of math. People think it's like a math test and a verbal test. This is not true. The GMAT and business schools do not care whether or not you can do probability and combinatorics. It helps a little bit, but not really what business school is about. This is a test of poise, a test of stamina, and a test of creativity. Basically, can you keep your stuff together when you're under pressure? Can you outlast your competitors? Can you keep focused in a really long, boring meeting with private equity people or investors, or in this case, in a long, boring test that you're in your 4th hour and suddenly they give you a reading comprehension passage on amoeba or invertebrates or something like that. And a test of creativity. People don't think of that. People don't think of standardized tests as a test of like, gosh, coming up with like brand new ideas, but it totally is. And you'll see that when we do critical reasoning, when we do reading comprehension, you're going to be asked, gosh, what might make this argument true? What might make this argument stronger, and what would make it weaker? And you have to come up with new ideas. All that to say, the timing of the questions, the fact that they ask you to answer these questions in 2 minutes or less, is not a bug. It's a feature of the test. And so if they could give you unlimited time to do things, but then everybody would get it right, and it wouldn't be a standardized test. Most people would do well, and then they wouldn't be able to differentiate. the job of the test makers is to make you miss and make you take too much time. And I will show you how to go faster and how to get things right. And it's actually a lot easier than you think. So, Obi, thank you very, very much for that. Sarah, what are the 1 or 2 things you want to get out of the course?
I must say thank you because you have addressed some of my concerns, and I feel comfortable and confident that this is going to be worth my while. So one of the things that I struggle with, agreeing with what Jordan and Obi has said, apart from the strategic approach to answering question, very fast, I struggle with accuracy, and I also would like to manage my time so well, like to be so composed, to have the confidence that this GMAT, I can conquer it. So I am hoping that I get that out of this this
Great.
experience.
Okay.
Yeah.
Good. Well, I think you'll get both, and certainly like being more accurate and getting things done more quickly. Those are core elements of any great test taker. So we will work on both of those. Thank you, Sarah. And last but not least, Alex, what would you like to get out of this course?
Basically just get a 700 score, or hopefully better. I'm struggling with verbal. I'm pretty good with math, so the math part is not an issue. It's mostly the verbal.
Okay. Well, everything you can test is to be conquerable. To get a 700 means you are beating 90% of the test takers. Most of my students do it, but it comes with after hard work. So if you're willing to put in the work and you're willing to use the techniques that I give you, you'll get there. Okay.
Okay.
All right, let's get started. Quant today, we're going to cover a lot of fundamentals. We're going to get as far as we can. We're going to do number theory, arithmetic, and some algebra. I do this by going step by step through all the slides and doing every single problem. Takes a long time. We will probably go all the way until the time limit tonight, but we won't always go the full 3 hours. So fair warning about that. But I'm lately been taking a different approach, which actually works much better for the student and certainly works much better for me. I'm going to teach you a bunch of stuff up front. And on this cover slide, we're going to learn most of the things that we're going to cover in the lesson. But I just want to talk it through. I want to cover it by talking through it in about 10 minutes. And then we'll go through the 38 slides or whatever we have. Okay? That sound good?
Good.
All right. So number theory is about positive and negative numbers. It's about integers versus non-integers. It's about prime numbers versus non-prime numbers. So the very first thing is what's a positive number? What's a negative number? So who can define a positive number? Just yell it out.
Number greater than 0.
There you go. Oh, we got it. So any number greater than 0, that's a positive number. And a negative number is?
Any number less than 0.
You got it. Oh, being less than 0. What's a non-negative number?
Absolute value of any number greater or less than 0. Wrong?
No, not any number greater or less than 0. That's not right.
Would it be any positive number including 0?
A non-negative?
Yeah.
2?
Well, 2 is a non-negative. That's right. A non-negative is any positive number or 0.
0.
Okay. So whenever you see the word non-negative, you better think, oh, well, it could be positive or but it could also be 0. Sarah, you have an enthusiastic participant behind you, so.
Yeah, you should mute me. You can mute me.
I'll mute you. Yeah, that worries.
Yeah, thanks.
I like extra participants, and to be honest, Sarah Jr. would be a fun person to teach the GMAT stuff to as well. And I've taught people as young as 15 to take the GMAT, but I think that person sounded slightly younger than 15. So, so non-negative, positive, negative. These are things you got to know. You got to know what an absolute value is. An absolute value is the magnitude of a number, which is basically how far it is from 0. So the absolute value of 3 is 3. The absolute value of negative 3 is 3. Absolute value marks look like this. Okay, so little bars. Okay, so the magnitude of something, absolute value. Other things to know, gosh, how do you get a positive number and how do you get a negative number when you add things together or multiply things together? Here's what I want to say. If you can add 2 and 3 or negative 2 and 3, you don't need to memorize the rules. If you cannot add negative 2 and 3, you need to memorize rules. So how do you add negative 2 and 3? What's that? What's negative 2 plus 3?
1.
1. What's negative 3 plus 2?
Negative 1.
So when you have one negative and one positive number, maybe you'll get a positive number, but maybe you'll get a negative number. You see how that works?
Yes.
Yeah.
All right. When you add 2 positive numbers together, can you get a negative number? Is there any way to get a negative number when you add 2 positives?
No.
No way. You're just going to get a positive number. What about when you add 2 negatives together? Is there any way to get a positive number in that case?
No.
No way. No, you're adding 2 negatives. You can't get a positive number. You're adding 2 negatives together. Okay, these are the kinds of things you need to be able to do. Not super complicated, but the kinds of things, number properties, number theory that you need to be able to do quickly and all the time on the GMAT using just super simple numbers. Usually I use 2s and 3s. Okay, let's do a little more complicated stuff. When you multiply stuff together, 2 times 3. First of all, when you multiply 2 positives together, do you always get a positive?
Yes.
When you multiply 2 negatives together, what do you get?
Positive.
Also a positive number, right? When you multiply a negative times a negative. Yep. When you multiply a negative and a positive, what do you get?
Negative.
Negative. That's the only way to get a negative number, is when you have 1 positive and 1 negative. Okay, these rules work the exact same for division. The only way to get a negative number when you divide is have 1 be positive and 1 be negative. Right? Does that make sense? All right.
Yes.
Cool. I have another question. Let's do odds and evens. What's an odd number? What's an even number?
2, 4.
Yeah, you got it, Alex. You nailed it. So 2, 4, 6. Anything that is divisible by 2 is an even number. Okay. An odd number, everything else.
Except
0
1.
is even. 0 is even. Okay, so now you know that. Fun fact. Everything that's not an even number is an odd number. Sorry, every integer that is not an even integer is an odd integer. Okay. Good. All right. So when you're multiplying numbers together, gosh, how do I get an odd and how do I get an even? Let's use those same numbers. 2 times 3, is that odd or even?
Yeah.
What is it?
Even.
Even. What about 2 times 2? Is that odd or even?
Even.
Even. What about 3 times 3?
Odd.
Odd. Okay, good. We just found out the only way to get an odd number when you're multiplying is to have 2 odd numbers. Okay? If you cannot do that, you need to memorize the rule. If you can do that, you don't need to memorize anything. You can figure it out in under 5 seconds. Okay, that's what I do on the test. But you're welcome to memorize rules if that helps you. All right, so now we know a little bit about odds, a little bit about evens, we know a little bit about positives and negatives. What about exponents? Okay, a little bit about exponents. Anything raised to the power of 1 is itself. Cool?
Yes.
All right. So when you square something, that's just that thing times itself again. So what's 2 times 2 again is what?
4.
All right. And what's 3 times 3?
9.
Good. All right. So 3 to the anything is going to be odd because you're just going to have a bunch of odd numbers. But it's also going to go in a certain pattern because watch what happens here. 3 to the 1 is 3, 3 to the 2 is 9, 3 to the 3 is 27, 3 to the 4 is 81, 3 to the 5 is 243, 3 to the 6 is 729, I think. 3, 9, 7, 1. 3, 9. What do you think the 3 to the 7th? What do you think the units digit is going to be of 3 to the 7th? 3, 9, 7, 1. 3, 9. What do you think the next one's going to be?
7.
7, that's right. Every number does this when you raise it to power. So 1, 2, 3, 4, 5, 6. So when you raise 1 to any power, the last number is going to be 1. And that also works for something like 31, because 31 squared is 31 times 31. Those units digits are 1. What do you think the units digit is going to be of 31 times 31?
1.
What do you think it's going to be?
1.
1, you got it.
1.
You got it. So anything that ends in the units digit 1, when you raise it to anything, it's going to be 1. Same thing actually for 5s. Because what's 5 times 5?
25.
25, down on down. Same thing for 6s. Same thing. So same thing for 5s and same thing for 6s. We just did 3, 3, 9, 7, 1, 3, 9. And then I'm not going to fill out this whole chart, but let me just give you 2. What's 2 to the 1? What's that? What's 2 to the 1? What's the units digit of that?
2.
2. And what's 2 squared?
4.
2, 4, 8, 6, 2, 4, 8, 6. So everything repeats in sets of 4. Okay? That is a kind of random, little idiosyncratic thing, but it comes up on almost every GMAT I've ever taken. That thing where, you know, you'll have like, what is the units digit of 2 to the 39th times 3 to the 37th? And you're like, oh, well, all that is 2 to the 39th is going to end in an 8, and 3 to the 37th is going to end in a 3, so 8 times 3 is 24, it's going to end in a 4. Okay, so you just need to know that little trick. Okay, let's go back to the more simple stuff. We've done some exponents, we've done positive, we've done negative. You know what? I think that's it for now. That's plenty. That's most of what we're going to cover in this deck. So why don't we go into the deck and have you do some problems? Sound good? All right, let's do it. Okay, problem solving and data sufficiency, those are the two types of problems you're going to face. Problem solving is like every high school math question you've ever faced. Data sufficiency, very idiosyncratic. We will do lots and lots and lots of practice in both, but especially data sufficiency. All right, problem solving questions look like that. Complicated words on the left, answer choices on the right. We're not going to do this one in particular. Data sufficiency looks like that. It's going to end in a question mark right here. And I will give you a secret right now. The answer to every single data sufficiency question you ever see is the exact same thing. It's true. Every data sufficiency question you ever see, the answer is, how the heck do I know? I don't know. Who knows? If you know the answer when you get to the question mark, you have read the question wrong. So back up and read it until you get to the question mark, and then your answer better be, how the heck do I know? I don't know. How many solar panels are in a row? Who knows? Could be a lot of things. Okay? You have to be confused at that question mark. If you know the answer, you're dead meat. You read it wrong. You need more information. That's the whole point of data sufficiency. They're going to give you two statements, and the way to read it is, given statement one, can I answer the question?
Right.
And then you're going to forget everything you read about statement one, and you're going to say, given just statement two, can I answer the question? Definitely yes or definitely no. If you still can't answer the question, then you combine them and say, all right, let's say I'm given both pieces of information. Now can I answer the question? Definitely yes or definitely no. That's it. Those are the only steps. That's all you have to do on data sufficiency. We will do those over and over and over again. Okay? Any quick questions before I move on?
Can you go over prime numbers?
Sorry,
Yeah, we will do prime numbers, I promise. Jordan, what were you going to say?
I just had a question. So I was wondering if you recommend reading answer choice 1 and 2, and then I think before you read the question, or if you recommend reading the question first. I just didn't know if there was, okay.
Yeah.
Makes sense.
Do not read the statements before you read the question. There will be, nope, never mind. No, not on math. Always read the question first.
Verbal.
Okay. Yeah, we'll get to verbal. Okay, let's get into this stuff. All right. Positive and negative numbers, you know it. 0 is neither positive nor negative. Okay? If it says non-negative, that just means positive and 0. Okay? All right. We have done all of this. Addition, subtraction, multiplication, division. We've already, we know how to get positive numbers. We know how to get negative numbers. And we have done this. When you have something squared, you're always going to get a positive number. When you have something to the third or the fifth, you might get a positive number. You might get a negative number. So 2 times 2 times 2 is 8. Negative 2 times negative 2 times negative 2 is negative 8. So when you have an odd exponent, x to the odd power is the same sign as x. So x to the even power, always positive. Okay? Does that make sense? Yeah? Alex, we good?
Yes.
All right. Okay. I'll let you try this one. Test some numbers, see how you do. Here's what I'm going to do. I'm going to go away. I'm not like actually going away, but like I'm going to take my microphone off and take the picture off so that I don't distract you. I'm going to give you a minute and 50 seconds. Try this out, see what you can come up with, and then we're going to go around the horn, see how you did, and then we'll discuss the solution. So go ahead and try it out right now. Okay. Let's do this. Go ahead and type in the answer choice that you got, the letter of the answer choice that you got into the chat box. Let me know what you got. We have one answer here. Thank you, Jordan. Now, Alex has crushed it. Obi, 100% correct. And Sarah, what do you think? Waiting on Sarah.
Am I supposed to see their answers?
Nope, it's only for me.
Oh, okay.
Sarah? Okay. Yay! Sarah got it right. Okay, so 3 for 4. Let's talk. Well, actually, Obi. Well, who's confident that they got it right?
Oops.
Alex, do you want to tell me how you got it?
I'm not proud of it though. I just try every number that I between.
That's not a bad way to go. So I think this is what I did. I just said less than 5. So integers less than 5. 4, 3, 2, 1, 0. And then I have -1, -2, -3, -4, -5, and then I'll try -6 over here. So anything 4 through 0, you're going to get positive times a positive times a positive, and that's going to be greater than or equal to 0, right? Right? Everybody should be like, obviously, yeah, right?
Yeah.
I mean, Eric, who do you think we are? I'm not like an idiot. So, so these 5 you get automatically. You just get those automatically. Now, -1 makes this 0, -3 makes this 0, and -5 makes that 0. So that's going to work, that's going to work, and that's going to work.
Mm-hmm.
Okay, so now all we have to do is test -2 and -4. When you plug in -2, you get -1, 1, and 3. Uh-oh, negative times a positive is a negative number.
Mm-hmm.
So -2 does not work. When you do -4, you get -3, -1, and 1. 2 negatives and a positive is greater than 0. Anything -6 and below gives you -5, -3, -1 gives you 3 negatives, and that's not going to work. So -6 and below, forget it. You're done. 9. All done. Okay. Here's now I've done this like a billion times, but when you do this, you should see I don't need to test 3 and then 2 and then 1. 4, 3, 2, 1, 0. Those are all going to give me positive numbers. All right, those are all the same. They're same kinds of numbers. So here's what most people who have not had me as a teacher do when they are told to pick numbers. Okay, I'm going to test 2 and then I'm going to test 3. No, don't do that. When you pick numbers, when you test numbers, test different kinds of numbers. Test every different kind of number that they allow you to test. So sometimes they won't even say how many integers. Sometimes they'll just say how many numbers. So when they say how many numbers, don't test 2 and 3. Test 2 and -1 and +1/2 and 0. You got to test different kinds of numbers because you're an explorer. You're a spelunker. You're a thirsty little honey badger looking for the right answers. So you don't want to just you don't want to be testing. You don't want to be digging. In one spot and say nope. Like you don't want to be digging in. What's a bad place to dig? Anybody? What's like a bad digging place?
No idea. Water.
Water. Yeah, you don't want to be digging a ditch and be like, you know what? It's impossible to dig a ditch because every time you put your shovel in the ground, all you get is a bunch of water. It's like you're in the ocean. You're in the middle of the ocean. You have to go to land and find a different place to dig. There are other places to dig. So anyway, that was a terrible analogy. I will do better with the analogies as the course goes on. But the point is you want to test different kinds of numbers.
Yeah,
okay, everyone understand?
Do you have an exact type test, or we just kind of come up with it on our own, like 0, 2, -3, a fifth? Or should we have a certain strategy like test prime numbers and even and odd and a 0? Or
nope. I think in general, I try to keep the numbers as small as possible. Try to keep it 2 and 0 and 1/2, and I try to avoid the number 1 because weird things happen with 1, and I'm also very careful with 0 because weird things happen with 0, but it's not like there are magic numbers that work and other numbers that don't work. You just try to keep it small and try to work quickly and test different kinds of numbers. Okay, Sarah, I think you had something. I'm sorry, I just saw the unmute. So what did you want to? I didn't want to miss your comment.
So I was gonna say that my approach. I started out well, and I figured out I was not going the right way, but I kind of tried to solve it quickly. I was able to identify the first 3 numbers, and then I started trying your approach.
First 3 numbers?
The first 3 numbers were the -1, the -3, and the -5.
Okay, all right, okay.
Just from that equation. And then even though I got lost because I was panicky because I knew I was running out of time, but when I looked at the fact that I needed numbers that are greater or equal to 0, I figured out maybe 9. So I was just lucky to get the 9, not that I actually walked towards, I just did a lucky guess or a smart guess.
Yeah.
To pick 9.
I'll say 2 things about that. First thing is when you guess correctly, the GMAT gives you 100% credit. So you got it right. The second thing is you're not going to get it right all the time. And so if you get it right for the wrong reasons, you really lucked into that one, Sarah, I will tell you. You need to practice this again.
Yes.
So class, go through it again. There's something you said. You said you needed to have positive numbers. You do not need to have positive numbers. You need to have the product be positive. So look what happens when you plug in -4. You get 2 negative numbers. But a negative times a positive, that works. Okay? So, when you get 4, 3, 2, 1, 0, you plug any of those in, you're going to get 3 positives times each other. That's fine. That's always going to work. But you may not always get positive numbers.
That's right.
Okay, so be careful. I will always use the correct terminology when I'm talking about math. Most people do not use the correct terminology.
That's right.
It's okay not to know all of the, I went to MIT, I'm a stickler for this stuff. It's okay not to use it, but it's not okay not to use the correct terminology if the incorrect terminology is causing you to miss stuff. So I won't, I'm not going to insist that you get everything by the book. I'm here to help you get the right answers on the test. I'm not here to help you write your dissertation on mathematics or English literature or whatever. Okay, but to the extent that correct terminology helps you get the right answer, I'll point it out. Okay, sound fair?
I have a question.
Yeah, thank you.
Sure.
Was that 2 minutes that you gave us to solve it?
Yeah, it was a little more.
Oh, okay. Okay.
All right, so all right, let's go on to the next. Okay, let's try this one. I will give you exactly 90 seconds, and I'll come back in exactly 90 seconds. Go. Okay, guys, go ahead and answer if you have not already. Okay, Sarah, what do you think? No penalty in class for getting answers wrong. There is only a penalty if you do not answer. Then I will be upset. Okay, great. All right. Alex has answered twice. Let's see what goes. All right. All right. So, is P positive? What's the answer?
I don't know.
Who knows? That's exactly right. So, Alex, you're right about that. So, is P? I don't know anything about P. Could be anything. So, all right. Now let's see what we get. So here's how to read it. Given that P cubed is equal to P, is P positive? Well, maybe it is, because maybe P is 1. If P is 1, P cubed is equal to P, and P is positive. But maybe it's -1. Maybe it's 0.
Right.
So, so maybe yes, but maybe no. Is P positive? Given statement 1, I don't know.
Right.
Don't know if it is. Maybe it is, but maybe it isn't. So now it's not A and it's not D. We are down to B, C, and E. All right, so now forgetting everything I just learned, I'm going to test statement 2 alone. Given that the absolute value of P is equal to P, is P positive? Well, maybe it is, because maybe P is 1, right? Can you think of anything where P is not positive and the absolute value of it is equal to it?
0.
You got it. So maybe it is, but maybe it isn't.
Mm-hmm.
So given statement 2, I don't know. I don't know if P is positive. All right, so now let's test them both together. Given that P cubed equals P and absolute value of P is equal to P, is P positive? Well, maybe it is.
Maybe it is.
But maybe it isn't. So it's E.
I was right.
You were right the second time. Come on. Come on.
And everybody else is wrong this time?
Everybody else is wrong. Okay. Does that make sense?
Yeah.
How much math did I do?
Not a lot.
Not that much. How many letters did I use?
3.
3 numbers.
Yeah, 3 numbers. How many letters did I use?
Letters? No.
None. I almost never use letters.
Oh.
If you are doing complicated algebra, because God bless her soul, some math teacher back in middle school or high school taught you to always write down every step and she'd give you partial credit for it. If you are still doing that, stop it, because you get no credit for it on the GMAT and it probably is wasting your time. The only thing you get credit for is getting the right answer. You don't get credit for long-winded, algebraic disquisitions, roads to nowhere. Okay? If you speak algebra and you are so comfortable in variables that you just swim in them and your mind is like that blackboard and Good Will Hunting and like everything's good, if that's how you think, go for it. Use it. If you don't. You don't get any credit for using algebra, and certainly not with me. You only get credit for the right answer in 2 minutes or less. Okay? I'm going to be a super hard ass about that, because people love to show how much work they did. And I do not care how much work you do. I only care what your answer is, because that's what your score is going to get based on. Okay? Let's keep going. Told you this would be fun. I'm having fun. Okay, even and odd numbers. We've talked about what even and odd numbers are. You know how to get an even number, know how to get an odd number. Okay. Which of the following must be even? Well, I'm going to give you a quick hint. One of these numbers if you multiply anything by an even number, like if you multiply 9 by an even number, or an even number by an even number, what do you get?
Even.
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 One of these answer choices has a 2 in it. What do you think the answer is going to be?
It's going to be negative.
That's it. You can just short circuit it there. Or you can say if non-negative integers x and y are not both even, all right, here's what they want you to do. They want you to be like x and y are both odd, but that's not what it says. It says they're not both even. So maybe it's that, okay? So those are the two lessons. Number one lesson of this is sometimes there's like an easy answer just bursting out of the answer choices, and it's super easy if you see it. The other thing is read the question carefully. Not both even does not mean both odd. It means they're not both even. Maybe they're both odd. Maybe one of them is even.
Is this
Okay?
a 100 level question?
Oh, hold on. What's that?
I said, is this a 700 level question? What level of question is this?
This is a 500 level. This is a middle question. This is not a hard question.
Okay.
We have not gotten to the hard questions yet. I'll let you know when we get to the hard questions. Alex, what do you want to say?
No, nothing. I'm good, thank you.
Okay. All right. Let's keep on keeping on. All right. All right. I'll let you do this, but let's do it quick. So go ahead and do the best you can in 90 seconds. All right. Ready? Go.
The sum of the integers is even. Let's see. 2 plus 4.
Okay. If you have not yet answered, go ahead and answer now. All right. Thanks, Alex. Thanks, Jordan. Thanks, Sarah. And Obi, what's going on? Okay. All right. We have 4 different answers. Let's see if one of you is correct. All right. Is the product of a certain pair of integers odd? I bet all of you can get this one correct. What is the answer? Is the product of a certain pair of integers odd? What's the answer?
I don't know.
Who knows? You got it. Jordan nailed that one. All right. Very good. Who knows? Nobody knows. Nobody knows. All right. Certain pair of integers odd. By the way, what makes the product of a certain pair of integers odd?
2 odd.
Them are odd.
That's right. They might have well just asked you, are both integers odd? Because that's the question. Are both integers odd? Okay. Number 1 says the sum of the integers is even. Okay. well, maybe it's 3 plus 3, but maybe it's 2 plus 2.
Right.
So that alone, not enough. Bye-bye A, bye-bye D.
Oh no.
Statement 2 says at least one of the integers is odd. All right, well, maybe it's 3 and 3, but maybe it's 2 and 3.
Right.
So that alone, not enough. All right, now both. The sum of the integers is even. At least one of the integers is odd. Are both of the integers odd?
Yes.
Anyone get C?
First time, huh?
Alex got it. You got it. All right. How much math did I do?
Not much.
Not very much. How much very sort of forceful, with emphasis, logical reasoning did I do?
A lot.
A lot. That was pretty much most of it. I wrote out 3 pairs of numbers. One where I had 2 odds, one where I had 2 evens, and one where I had an odd and an even. And then I just tested them. And that's it. Right?
Okay.
Most of you, and if you read the explanations of all of these problems in the back of the book or in whatever answer key there is, the answer key is written in math gobbledygook. It is written in a way, it is like very formal. It's written in a way you will never think. You would never think to do that. I don't think like that. Most people who do really well on the test don't think like that. And I'm not going to explain it in that way. I'm going to explain it in plain English. Anybody can get these right if you know what's going on. So put that is the product of a certain pair of integers odd into plain English. We got 2 numbers, it's a pair of integers, and it's asking us if you multiply them together, are you going to get an odd number? Well, there's only one way to do that, and that's if both of those numbers are odd. All right, so now let's see if both of those numbers are odd.
Really? But this is confusing for me, really, because okay, so let me tell you how I approach this question. Maybe something is wrong with my thought processes that I need to restructure. So when I read the question, it's like it's the product of a certain pair of integers odd. We don't know, right?
Who knows?
And then it gives us, okay, let's try number 1. It says the sum of the integer is even. So what I did was I brought out 2 integers that would be even. So what I did was, okay, I took 2 and 4, and I took 2 and 6, and they would be even. What I did was I found the product of the 2, and they are not odd. So my answer is no.
Why didn't you think of 3 and 3? You dug in the same place. You were digging, like, let's dig in the water over here, and then let's dig in the water over there. You didn't even try land. Okay, the point, you can't choose 2 and 4 and 2 and 6. You can choose 2 and 4 and 3 and 5. Or just keep it tight. Choose 2 and 2 and 3 and 3. You got to choose different kinds of numbers, not just different numbers.
Can I say something?
Yeah, Al, go ahead.
Because I've been studying a lot of data sufficiency, so that's why I can understand that. Try to be devil's advocate. So every time you think you have an answer, try to prove yourself that it's not. And if you can't prove it that it's not, then you're right. So that's basically what it is.
But yeah, that's what critical reasoning means. So we obviously have a depressingly low amount of that in the United States right now, given how politics is going. But if you see something where you think you're right, say, listen to the other side, or think about how could I be wrong? How might it be the case that this conclusion is not correct? really put some effort into thinking how might that not be right. So I chose 2 and 2, 4 and 4. The sum of those, both of those, the sum is even, and the product is not even. So there, maybe I have enough. Is there any way to get 2 numbers where the sum is even, but the product is odd? 3 and 3. Done. So Alex, that's really good advice. Sarah, does that make sense? I don't mean to be like tough, but I do kind of want to be tough out of the gate. I'll be sympathetic, I promise.
Yeah, that makes sense. I guess I have to like immerse myself in this kind of questions so that I can it can become second nature.
It will. It will. Practice, guided practice makes better. I won't say practice makes perfect, because if you practice on your own and you're not doing it right, then as one of my soccer coaches used to say, practice makes permanent. You don't want to don't want to practice something that in the wrong way. But guided practice will make better and better. Okay, so let's keep moving through. Okay, absolute values we have done. We know what an absolute value is. It's the magnitude of something, the distance to 0. With variables, when you take the absolute value of something, absolute values of numbers have 1 value, so the absolute value of -3 is 3. Absolute values of variables usually have 2 values. So if you say the absolute value of x is 3, well, x might be 3, but x might also be -3. Okay, and there's a quick way to do this. When you see the absolute value of x is 3, you do a positive case and a negative case. And the way to do a positive case is just eliminate the absolute value marks. So just say x is 3. And the way to do a negative case is you multiply this side of the equation by -1. Okay, so this works for something simple, but it also works for something a little more complicated. So if I have the absolute value of x minus 2 is 3, okay, maybe x minus 2 is equal to 3. So maybe x is 5. Does that make sense?
Mm-hmm.
So far, so good?
Yeah.
But maybe x minus 2 is equal to -3. And if that's the case, you add 2 to both sides, and you get x equals -1. So maybe x is 5, but maybe x is -1. So there's the positive case, where you just remove the absolute value marks. And there's the negative case, where you multiply this side of the equation, the right side of the equation, by -1. Sound good?
Good.
All right. Let's do an example. Go ahead and try that one on your own. I'll give you 30 seconds. Go. Okay, guys, what do you think?
Seven and -7.
Nope.
Huh.
And then -2.
Yep. Jordan had I think Jordan and Opie got it. So Jordan, tell me how you got it.
Sorry, I'm just jumping back in.
Yeah.
So with this, you just said to the right side of the equation, you're going to take that and times it by 1, right? So I have the 2x minus 5 equals 9, taking the positive case. And then a separate would be the 2x minus 5 equals -9.
Mm-hmm.
So then once those are separated, we just do the math of taking the 5 and putting it over. Exactly.
You can plug it back in if you want to test it, and you'll just to make sure that when you plug in -2 for x, you get 2 times -2, which is -4. -4 minus 5 is -9. The absolute value of -9 is 9. 2 times 7 is 14. 14 minus 5 is 9. The absolute value of 9 is 9. Okay, does that make sense?
So is that always the case with absolute values, as you can take that right side of the equation and, okay.
There is a more complicated way to teach that, but that is the easiest way to teach it, and it always works. Okay? Make sense?
Yeah.
All right, let's keep on moving. All right, try this one. I will give you one hint, which is that when you multiply or divide by just treat this like an equal sign. But for the negative case, whenever you multiply or divide by a negative, and in this case, the negative case, you're multiplying by a negative, it's kind of like you have to flip the inequality sign. Okay, that is the one thing I will tell you. Whenever you multiply or divide by a negative, you have to flip the sign. So do this exactly like we did the previous one, except for the negative case, you have to flip the sign. Okay, so go ahead and try it. I will give you 2 minutes. Go. Okay. Jordan, thank you for your creative answer. What is the? You're not wrong, but what is the letter answer? You got it. All right. Thank you, Alex. Thank you, Jordan. So far, so good. How about Obi and Sarah? What do we got? I've never had everybody get this question correct. So far, we're 2 for 2, though. We had someone abdicate. Someone just threw themselves off of the metaphorical bridge. which is always sad. Hate to have that happen the first lesson. And all right. So Jordan, do you want to explain this one? You are king of absolute values right now.
It's about time I got one right, so I'll just take it. So with this, setting up the exact same way, we did the x minus 3/2 is less than 9/2. And then to take the other side of that, we have x minus 3/2 is greater than the negative 9/2.
Okay. If you got this far, you probably got it right. Okay. Here's the positive case. Just remove the absolute value signs. And then the negative case, same thing. You do the same thing as the equal. When you have the equal sign, you multiply the right-hand side by a negative, and you flip the sign because I told you to. Okay. All right. So Jordan, now what do you do?
So now we're just doing the algebra, or sorry, the addition, adding the 3/2 to the other side. So we have that x is, oh, sorry, I lost my note here. So we have that the x minus 3/2 is good. I'm sorry, I got sorry.
I got you, Jordan. I'll take you home from here. I got you. I'll get you home from here.
My computer was lagging, so I couldn't see where we're going. So sorry.
No worries. So you add 3/2 to you add 3/2 to both sides on the left-hand side, and you get x is less than 6. You add 3/2 to both sides in the negative case, and you get x is greater than negative 6 over 2. So x is greater than negative 3. All right. So x is greater than negative 3 and less than 6. So it's between 3 and negative 6. Not 18, not 9, not negative 9. Is it negative 4.5 or is it positive 4.5? This is negative 4.5. And this is 4.5. There you go. That's it. A little bit more math on that, but positive case, negative case. That's all there is. Okay? Obi, Sarah, any questions?
Yeah, I was confused by flipping the sign. I wasn't exactly.
So if you got that very first step right, then I would have gotten the answer.
Yes. Very first step. So when you multiply or divide by a negative, you have to flip the inequality sign. So if you had something like negative 2 times x is greater than 6, then you divide by negative 2, and then you flip the sign. So x is less than negative 3. And that makes sense, right? Because if you had negative 2 times like negative 10, you're going to get 20, and 20 is greater than 6, right? But if x was 0, you'd have negative 2 times 0, and 0 is not greater than 6. Yes? Obi, you okay? Did you have a heart attack?
Yeah, this is something I just didn't know the rules to this at all. So it's like I didn't even know where to start. So.
We're going to cover a lot of fundamentals in the context of questions. I don't take a lot of time to teach absolute values and inequalities and negative. If you are having, if you'd like some more practice with some of the fundamentals, I'm going to recommend a book. It's a $10 book. You can get it anytime on Amazon. It's called Math Review for Standardized Tests. I think it's volume 3 right now. It's by Cliff's Notes. It is it's like a $10 or $11 book, very cheap. That will teach you the fundamentals. That is something you can learn for $10. You can learn on your own. This is a more than $10 lesson, and I'm going to teach you the stuff as if you were a 700 student, because that's what I expect you to be. So if you need more of the fundamentals review, I highly recommend that book. I don't get any money from it, but it's been useful for hundreds of my students in the past. Perfect. Sound good?
Yep.
All right. Okay. I'm going to do this one for the sake of time in a minute. So want to put me on the clock? I'm going to do this in a minute. Tell me when.
Go.
Sarah, are you timing? Okay, good. Okay, I heard go. All right, if x is an integer, all right, so it could be like 1 or it could be like 2 or 0, is the absolute value of x over x less than 3 to the x? Wow, who knows? Maybe it is, maybe it isn't. It sure seems like the absolute value of x over x is going to be 1. Oh, but maybe it'll be -1. All right, so this left-hand side of the equation is always going to be 1 or -1, depending if x is positive or negative. It can't be 0, because if you divide by 0, I sink into a black hole and I die and nobody ever hears from me again. And I meet Stephen Hawking and God, and it's great. But I can't divide by 0. Very, very bad thing. So it's so either x is positive, in which case the left-hand side is 1, or x is negative, in which case the left-hand side is -1. Okay. Right-hand side, 3 to the something. Well, 3 to the 0 is 1. 3 to the -2 is like 1 over 9. 3 to the 1 is 3. 3 to the, 3 is 27. You know what? This is always going to be positive. So 3 to the x is always going to be positive. Maybe it's small positive. Maybe it's big positive. But right-hand side is always going to be positive. All right. So statement number 1, x is greater than 0. Okay, so what if, so 1 over 1, is that less than 3 to the 1? Yup. 1, so 2 over 2, is that less than 3 to the 2? Yup. If x is positive, that's always going to work. X is -3. Well, -3 over -3, so we get -1. Is that less than 3 to the -3? Yep, -1 is less than 1 over 27. That's it, D. All right, that took a little longer than a minute. Sorry about that. So a couple things. You have to know that this exponent rule, 3 to the -1 is 1 over 3 to the 1. 3 to the -3 is 1 over 3 to the 3. All right, that rule you have to know. There are 8 exponent rules. We will cover them. There are only 8 exponent rules. Once you know those, you do not need to know any other exponent rules. Also, you cannot make up your own exponent rules. I have always one student in every class who desperately wants to create an exponent. He's just like a very creative exponent person. It's like, I know, I've found a 12th exponent rule. No, you haven't. You just made it up and you didn't get it wrong. And Fox News is like, I'm tired of these liberal elites saying you can only have 8 exponent rules. Anyway, so one of the exponent rules you have to know is when you raise something to a negative exponent, you just 1 over it. 1 over whatever the thing is. So 3 to the -3 is 1 over 3 to the 3. I will make fun of all manner of media in this course, but anything I find partisan and illogical, I am not a fan of. All right, so
I have a question.
Yeah, go ahead.
The way I was solving it, I simplify the left side of the equation, so I had either -1 or 1.
Okay.
Right, and then that's the way I was doing it. Is that also safe to do it?
Well, I mean, yeah, that's what I did. I mean, I said the left-hand side of the equation could be 1, could be -1. That's the left-hand side of the equation. And then the right-hand side of the equation could be a lot of things. It's always going to be positive. Could be small positive, could be big positive.
All right.
If it did not say integer, then this would not have been enough. Because if you had like 0.1 divided by 0.1, is that less than 3 to the 0.1? So basically, is 1 less than the 10th root of 3? Nope. But it did say integer. So when it says x is greater than 0, that means the smallest thing x can be is 1.
Right.
Okay. This is a 700 level question. It requires really, really, really solid exponent rule knowledge, and you have to be super careful with the numbers that you pick. Okay. Let's move on. Let's do a few others, and then we'll take a couple minute breaks just so you can stretch your neck a little bit. All right. Number 32: factors, multiples, remainders, prime numbers, etc. Okay. Multiple of an integer is that number multiplied by an integer. So give me a multiple of 3. Give me an example.
X, 9, 12.
All right, 12 is a multiple of 3. Give me a number that's not a multiple of 3.
25.
25. Awesome. All right. A factor is also called a divisor. Is an integer that evenly divides that number without leaving a remainder. So give me a factor of 24.
2.
Okay.
4.
Anything else?
4. 8.
What did you say?
4.
4 works. I heard 8. 8 works. Okay. Generally, factors and multiples refer to non-negative numbers. Okay, great. Every positive integer is both a factor and multiple of itself. 1 is a factor of every integer. 1 is also the smallest factor of every integer. And 0 is a multiple of everything. So, all right, finding the factors of a number. There are few different ways to find factors of a number. When you have a number that's relatively small, like 36, I'm going to recommend a technique I call factor rainbow. Factor rainbow is finding the smallest factor. What's the smallest factor of anything?
1.
1. And 1 times what is 36?
36.
All right, that's it. What's the second smallest factor of 36?
2.
2 times what is 36?
13.
18. What's the next smallest factor of 36?
3.
3 times what is 36?
12. No.
What's the next smallest factor?
That's 12.
4. No.
4 times what?
18.
I'm gonna pretend you said 9. And then what's the next smallest factor of 36?
6.
Oh, it's like a pot of gold at the middle of the center of the rainbow. So 6 times 6 is 36. So that's all the factors. We're done. How many factors does 36 have?
Look at that. That's 9.
5.
9.
Literally count up the number of factors beneath the rainbow.
Okay. Never mind.
9.
9 factors. There you go. Okay. So that's one way to find out there are 9 factors of 36, and those are the factors of 36. Now, if it just asks you how many factors, are there? Well, you can prime factor it. So prime factoring is a little bit different. So a prime number is a number that is divisible only by itself and 1. Okay? I'm going to say a very important thing. The smallest prime factor in the world is 2. 2 is the smallest prime factor in the world. There is no number smaller than 2 that is a prime number. 2 is the smallest prime number in the world. Is 1 a prime number?
No.
No. Why not?
I don't know.
Because it's smaller than 2. Is 0 a prime number?
No.
Why not?
Smaller than 2.
Smaller than 2. Hey, what about -1?
So,
No. Why not?
smaller than 2.
You got it. All right. 2 is the smallest prime number. You'll never miss. You'll never forget that. You'll never mistake 1 or anything else for a prime number. Okay. So give me a prime factor of 36. I don't know. Pick one out of the blue.
2.
Yeah, there you go. All right. 2 times what is 36?
18.
18. All right. So circle 2. That is inert. That is a prime number. What's a prime factor of 18?
3.
All right. 3 times what is 18?
6.
Okay. What's a prime factor of 6?
3.
2 times what is 6?
3.
Okay, so 36 happens to be 2 times 3 times 2 times 3, or 2 squared times 3 squared. Fair enough? Good?
Good.
Yeah.
All right, so that's the prime factorization of 36. Now, how do you find out how many factors there are? Well, check this out. Each exponent, so you have, these are the bases, and these are the exponents. You draw down each exponent to here. And then you add 1 to each exponent. And you multiply. What's 3 times 3?
9.
Is that how many factors 36 has?
Yes.
That's it. That works for everything.
Right.
Everything?
Everything. Let's check it out. How about 40? So 40, you could do 1, 40, 2, 20, 4, 10, 5, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 factors, right? Make sense?
Mm-hmm.
Or you could do 40 is 2, 20, 2, 10, 2, 5. 2 cubed times 5 to the 1. Okay, so let's bring those down. 3, 1, add 1, add 1. What's 4 times 2?
8. 4.
Cool, right?
I've never seen this before.
Like magic. Math magic. All right, let's do some real problems. Woo! Go ahead and try this one. I'll give you a minute and 40 seconds. Go.
P and Z, which of the following must be true, and Z is equal greater than 0.
Okay, looks like we have Sarah, Alex, Jordan, and Obi. What do you think?
Yeah, I don't even know.
Well,
Where to start with this? Probably look at the answers. Like I couldn't figure this out.
all right. Well, I think your classmates did this first. Your classmates said if yz yz plus b equals b, your classmates subtracted b from both sides first and found that yz equals 0. So if yz equals 0, what do you know about either y or z or both?
One of them has to be 0.
One of them at least has to be 0. And then they tell you that z is not 0. So what do you know?
Y has to be 0.
That's the answer. That's it. So Alex, Jordan, Sarah, great job. That is exactly right. You crushed it. And hopefully you got it for the right reasons. That B is just a distraction. As soon as you get it out of both sides, you're in good shape. Any questions?
So when I got the answer, I thought I got it too easy.
Yeah.
I was starting to doubt myself.
Don't doubt yourself. They make this, this would be too easy if they actually give you numbers. If they said 2 times 3 plus 4 equals 4, that would be too easy. But they're trying to distract you with, by using 3 letters. And that's the only reason why it's hard at all. But this is one of the easier questions. Don't second guess yourself. If you get it, you can double check yourself, but don't rehashing all of your work. Okay?
Thank you.
Let's do it. All right, go ahead and try this. Just plug in put the answer in the chat box as soon as you get it. Okay, what do you think? All right, so far, Alex is answering pretty much all of the answers.
Let's see.
For all of you. Right. It's just giving it away. All right, so let's do this for the rest of you. We're going to pick up the pace here. All right, if n is an integer, all right, so n could be like 5 or 6 or something. All right, and and n is between 4 and 10. Okay, so that means n has to be 5, 6, 7, 8, or 9. Those are the only options, right? All right, what is the value of n? What's the answer?
2.
Come on, what's the answer?
I don't know.
Who
I don't
knows? Nobody knows. That's the point of the data sufficiency question. All right, come on, guys. All right, n is between 4 and 10. Don't know what it is. All right, so now it says n is a factor of 32. How many of these numbers, these 5 numbers, are factors of 32? That's it. 6 not a factor of 32. 9 not a. 8 is the only factor. So if n is a factor of 32, and it's 5, 6, 7, 8, or 9, that's enough. All right, now if n is a factor of 24, it could be 8, but it could also be 6. But that is not enough. That's all it is. That's literally all it is. Yeah. Right. That groaning you feel is the wrongness leaving your body. It's good. It's like a good thing to get out. It's good. Just like get it. Like exercise. Exercise. You know.
I have a question.
Yeah, go ahead.
Because I basically simplified it to like 2. I found like the prime factor, and that's what I was working with. I don't know why. Instead of
you thought 32 is 2 to the 5th?
yes. So I was only using 2.
I have a quick question. Where does it say prime factor?
I don't know.
In your head. So don't do the problem in your head. Do the problem on the paper. So that is a good lesson to learn in practice. Really good lesson to learn session 1. But very frequently, and this will happen in verbal too, you will see a word or you will see an answer choice and you'll be like, aha, I am going to use my own words and then solve that problem. And that is not cool. You can do it, you'll get it wrong. So be very careful to read the words exactly as they are on the screen. Because as you do better and better, especially high 600 level questions and low 700 level questions will turn on one word or one symbol. Okay? And in this case, if it said n is a prime factor, okay, that changes it, but that's not what it says. That is not the problem. So do the problem that is on the screen, not any other problem. Okay? I promise it will work better if you do that.
So I
Sound
think
good?
I got hung up on trying to factor the numbers. So I actually started well. I wrote an integer, I give options of -1, 0, or 1. And then when it says 4 is
Wait,
rated,
what? Oh, okay, yeah, so you knew what an integer was, okay.
I started well. I actually got to n is equal to 5, 6, 7, 8, and 9. However, when I started factoring the number 1, the option 1 and option 2, I got hung up. I couldn't quickly do the math. But while I was factoring, I simplified the factor such that the numbers n, 5, 6, 7, and 8 and 9 did not pop up in the way I factored it.
How did you factor it? Did you use
So what
factor
I did
rainbow?
was I started from 32 and I said 32 is 2 times 16. And when I got to 16, I did 4 times 4. So I should have gone 2 times 8.
You could have done that. You could have done
So
factor rainbow like I taught you.
the 8 would have popped out
This also works.
because I was looking for the 5 and 9 in the factors. So I think this approach is better. Your approach is better because I can easily see the numbers I'm looking for in the factors. Yes. So I got lost in the simplification that I started confusing myself. Yeah, so I think that approach, but I stick to that.
Awesome. Yeah, Sarah, honestly, after you said your approach is better, I just had Celebrate Good Times just playing on repeat in my head, and I don't hear anything else. So, but I heard most of it, and it sounds good. Okay?
Okay.
All right, let's move on. Okay, prime numbers. The smallest prime number is 2. You'll never forget it. The prime numbers under 20 are worth knowing. The prime numbers after that is okay, but like you should know these 8 numbers. Okay, 2, 3, 5, 7, 11, 13, 17, 19. Those are super helpful to know. Okay, 2 is the smallest prime number. It's also the only even prime number. Super important to know. All right. This is fun. This one is kind of fun. I actually like this a lot. So go ahead and try this. Try this one. Remember, a prime number greater than 2. You don't have to choose a gigantic number. Choose a small, pretty small prime number greater than 2, and I bet you'll get this right. Okay, so go ahead, try this out. Go ahead and enter the answer as soon as you are ready. Okay, guys, it's time. Thank you, Sarah. Thank you, Jordan. Thank you, Alex. Obi, what do you think? All right. We are a split class, 2 Ds and 2 Cs. So let's check it out. Jordan, what do you think? What'd you do?
So with this, for the prime number, originally I chose 3, but then saw that might not work. So I chose 5 for the prime number greater than 2. And basically just took that. So we had the 8 times 5, 40.
Okay. Mm-hmm.
And then just factored out 40 and counted up the number of even divisors that 40 has. So you have yep.
Wait, is it 1?
So what'd you get? How many are even?
So I got the 6. Well, yeah, we got 40, 20, 10, 8, 4, and 2. So 6.
Yep. Guess what? If you do 24,
You have done the same thing.
same thing. One, two, three, four, five, six. No matter what you choose for P, as long as you do factor rainbow and count up the number of factors that are even, you're going to get 6. Okay? There's a virtue to factor rainbow. The reason I do factor rainbow like I do it is because you can see, like when you get to 24, when you have 3 times 8, then you just go to the next number and see if that works. And 4 is a factor of 24, 4 times 6. And then there's only one other number, it's 5, and then you're done. You can't go any further because you're already on the other side of the rainbow. Okay, so it kind of tells you when to stop looking for factors. Because factors come in pairs. Does that make sense?
Yeah.
Good? Are we good?
Yep.
All right. How are you doing? Do you guys need a break? Or do you want to muscle through? Up to you. I can do this literally all day long. I can go for like another 20.
I could take a break.
You want like a 4-minute break?
Yeah, that sounds good.
All right, so here's what we're gonna do. I am the Energizer Bunny of test prep, so you guys take a break. If someone wants to stick around and ask me questions, I will answer personal questions for the next, not personal questions, but professional questions for the next 4 minutes, and then the rest of you, we will start up again at 6:58 Pacific, 9:58 Eastern. Okay. All right.
Okay.
So, sorry, this is Jordan. I had heard that it was best to memorize all the prime numbers under 100, but you're saying that really we only need the ones under 20,
Yeah.
so those are the ones that are going to pop up.
That's right.
Okay.
Under 100 is a lot, and I don't have all the ones under 100 memorized. I think I know it to 50, probably. I could do it to 50, and then after that, I'd have to like think pretty hard about it.
Okay.
Yeah, whoever told you that is here. By the way, I don't know. People try to scare people all the time. I just it's not in my DNA. I can't do that. I'm not gonna do that to you.
That's good to know.
Yep. Yeah, Alex. Today is math. Thursday verbal. We will do math and verbal we'll alternate every other class, if that's okay.
I have because I received a schedule. I don't know, but it says Richard Swartz.
Uh-oh.
So,
Richard.
but the time it says for now, and I see that you're the only class that is happening now.
Yeah, I don't know. Richard is like a less funny version of me. Yeah, I don't know. This is what I want to do. I want to have Richard's another tutor for Ready4. He's very nice, I hear. But I would like to like get in a shark cage with Richard and like just like we each have scuba gear on, and then we have to take a GMAT underwater with sharks going around us. And then and the winner, like whoever gets the higher score, teaches the other person's classes for like 6 months. I think that. What do you think? Would you watch that? I mean, people watch Twitch all the time. Wouldn't you watch that? Would that be good?
I'd pay good money to see that.
I think it'd be awesome.
Wait, so you're the only teacher you're gonna be teaching every Tuesday and Thursday at 8 p.m.?
Yep.
Okay. And how many classes are there? 8?
It'll be 8, yeah. It'll be 8 classes, but there will be office hours. Office hours are special hours where you bring the problems, and I do whatever you guys want to do instead of me bringing the problems, and I take off the tie. Okay. The sweater stays, but the tie will go. Actually, come to think of it, now that I'm in LA, maybe the sweater will go. Maybe you'll see me sans tie and sans sweater. That would be very casual for me. So come to office hours, find out.
And the office hours are on Saturday mornings, correct?
Yeah, I think that's right.
Can I have your schedule, because I think I received the wrong one. Can I send you my email and you can email it to me?
Yeah. So I'm gonna put up my email right now. By the way, Jordan asked about recording. All of the lessons are recorded, but tonight, about 15 minutes ago, we had a wee bit of a glitch with the GoToMeeting thing, and I think it may have stopped recording about 15 minutes ago. So this is I know this is what all men say, but this has never happened to me before. But we'll fix it in the next class. Okay. Anyway, so this is my email. With great power comes great responsibility. Use this with care. But this is my personal email. Here is the Ready4 email. You can email tutor@ready4.com. Okay. Jot those down. Okay. I think we have Obi back. We also have Juan and Kenobi. Get it? No. Okay. And we are gonna finish this up, and we're gonna do some. No. That was pretty good. All right. So all right. Obi did not. Obi is silent. Obi did not like.
Oh, I'm back.
I like.
Heard that
All
before.
right. You've heard of Obi's like every day. Every day I hear that. Sorry, man. All right. Okay. Let's just finish out this lesson here. Okay. Let me talk to you a little bit about this. If X is the hardest one in the deck, you know what? It's the hardest one in the deck. I'm going to give you a shot.
Yeah.
Go ahead and do the best you can with in a minute and 50 seconds, and we'll come back and explain it. Ready and go.
Serious. Okay, so 4 and 25. 416.
Okay. What do you think? Take a guess, and because when you do not guess on the GMAT,
Okay.
GMAT thinks you got it wrong. So there is no penalty for guessing, but there is a penalty for not answering. When you don't answer, you get it wrong. So Jordan has guessed. Sarah has guessed. Alex has guessed. And Obi, what do you think? Okay. All right, we got mostly A's and one E. All right, let's talk about this. If X is a prime number.
Oh.
Wait.
Yeah. That.
It's right there. Literally, I have read one. If X is a prime number, I've only read 6 words. It's like 2 of the first 6 words. So X is a prime number. It's 2, or maybe it's 3 or 5 or something like that.
Right.
Is 10x cubed plus 20x squared plus 6x plus 4 divisible by x squared? Well, I'll tell you what. No matter what x is, if they said is 10x cubed plus 20x squared, is that divisible by x squared?
Yes.
Yeah, anything. No matter what you have for x, that's going to be divisible by x squared. So that part is actually totally not relevant. That is totally not relevant because no matter what you have for x, that's going to be divisible by x squared. So the only part that's really relevant now is 6x plus 4. Is that divisible by x squared? Maybe, maybe not. I'll tell you what, 6x plus 4, this is going to be an even number.
Okay.
Mm-hmm.
And then you're adding an even number to an even number. So guess what? You're going to have an even number on top. How many even prime numbers are there?
1.
1. That's it. If x is anything else except for 2, you're going to have an even number divided by an odd number. And that's not going to work out. So an even number is not divisible by an odd number, except for 1, but you can't get 1. Right? 42 divided by...
Oh, wait.
Wait a minute. 6x plus 4. I guess you could get like 42 divided by 3 or something, but 42 divided by 9. Anyway, 6x plus 4 divided by x squared. But this whole thing is basically saying is x 2? Is x 2?
I didn't get that.
So that's what's going on. So so if you get that, you could have just asked is x 2? Blah 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 blah. Is x 2 equal to 2? I don't know. Maybe it is. Maybe it isn't. And then number 1 says x squared is greater than 3, right? So x is at least 2. And x squared is less than 28. Okay, so it could be 3. All right, so maybe x is 2, maybe it's not. Statement number 2 says x minus 9, x minus 2. So x could be 9 or x could be 2. This is a little bit tricky. So they say if x is a prime number, is this whole thing divisible by x squared? So x has to be a prime number. So here, given this second equation, x can only be 9, which is not a prime number, and 2, which is a prime number. So I think B is enough.
What?
Yeah. There are 2 things, but it says x is a prime number. So statement 2 says x is 9 or 2. But up here it says x is a prime number.
This was hard.
That's hard, yeah. There's a chance that they might have said it was C because statements 1 and 2 together say that x definitely has to be 2.
Yeah.
I'll put up a strong case for B because the original statement says x has to be a prime number. 9's not a prime number. Anyway, that's the hardest one on the deck. If you want to review it. There's an explanation. There's an answer key to every single problem that we do. You can look at that at your leisure, and I'm always happy to go over it again in office hours. Okay, sound good?
Okay.
Here's what we're gonna do. We're gonna wrap number theory, and then I'm going to go back to super entertaining, teaching you from scratch, teaching you all this stuff. Those 10 minutes at the beginning of each lesson, I'm trying to give you the essence, the fundamentals, the key to what we're about to do. Everything else is detail, detail, detail. If you can get your knowledge so that when someone says, tell me what you know about arithmetic, and you can go on 10 minutes about some key properties of, you know, how to do that exponent rule that we talked about, or exponent pattern that we talked about, or go off on the, you know, the 8 exponent rules, you know, how to take a square root, something like that. If you can do that for 10 minutes and really get to the essence of stuff, you're going to be in such good shape on the GMAT. The problem is when you see math as a jumble of formulas, a jumble of unconnected little strings of numbers and letters that you'll never need again in your life. Okay? Your job on the GMAT is to know a small corpus of key concepts, and everything else you can figure out under pressure in time. Okay? And we will work on getting faster and faster and faster. But for now, that's it for number theory. Number theory, one of the hardest parts of the GMAT, one of the most important parts of the GMAT. And we start with it because it kind of shocks you into realizing what the GMAT really is. Not a math test. It's a test of poise. It's a test of stamina. It's a test of creativity. Okay? Any questions on the number theory that we did? This is my little end of lesson dance. It's called White Boy Shimmy. All right. So we did prime factorization as well. These are questions you can do at home. Slides 32, 33, 35, 36. Okay.
Where can I get the slides?
They will be in the folder that will be sent to you by Julie. So if you do not already have this folder, it will be sent to you between the end of this class and the beginning of Thursday's class. Okay?
Okay.
All right, so you'll have all the slides. This is good homework. Here's my rule about homework. The homework in the GMAT official guide is very high quality homework. If you have any spare time between now and the next class, please try that homework. It will really help you reinforce the concepts that you learned during class. If you have even more time and you're super serious about getting ready for the GMAT, also do the Ready4 homework. That is also helpful.
For what?
The Ready4 homework is the stuff at the top of the screen. So the number theory sets 1 to 3.
Oh,
number
okay.
theory sets 1 to 3. But I would prioritize the homework in the GMAT official guide. You should get that sent to you by Ready4. If you don't have it already, you will have it very soon.
When you say you want the homework done by next class, Thursday or next Tuesday?
It's best to have it done in between classes before the next class. If you can't do it by then, use the weekend to catch up.
Good.
I don't check homework because, first of all, we're up against, you know, there's too much to do already.
Yeah.
But also, this is part of the GMAT. This is why I don't teach SATs, is because, like, you're grown-ups, you're adults, and I can't be there to take the test with you. If I could, I would. I would definitely take the GMAT all day long. It would be a lot of fun for me. You'd be happy. It would be awesome. But that would be illegal and would not do favors for you in the long run, you have to do the work. It's like my trainer says, nobody does your abs for you, which is both very mean and also true. Nobody does your GMAT homework for you. You got it. You improve at your own pace. The other thing I will say is that I'm big into building students' confidence, because a lot of the test, and certainly a lot of being able to go fast, is having the confidence to choose a choice, stick with it, and move on. Confidence comes from earned achievement. So I'm not going to give you the answers and tell you that you're great and then you're going to feel confident. But when you do stuff on your own and suddenly you're getting answers right that you never got before, you're going to feel better about it, and you will have earned that, and that's all you. And so when you have earned your achievements, you're going to feel better and better, and there's going to be a virtuous cycle of score appreciation. And then your teacher will appreciate you. They'll be very happy. Okay? Sound good?
Yep.
Are you with me?
Sounds good.
Good.
Yes.
Okay.
Yes, we are.
Okay. Thanks, Sarah.
And
Sarah, you're growing on me. I kind of a little truculent, but also you're committed to it. I like that. I like it a lot. So all right. So let's do some arithmetic. Let me just peek ahead the lesson. Arithmetic is one of those fundamental skills that you've been doing ever since you first learned math, and it's stuff you use every day. Now, arithmetic and algebra are two parts of math that people either love, feel very comfortable with, or fear and really get very jittery about. I'm going to say one thing that I believe very deeply. Nobody is born knowing exponents. Nobody is born incapable of learning arithmetic and algebra. Okay? In Asia, we think of Asian cultures as people who do math with proficiency. They do not think of, and I know this, I used to go to China all the time for my job when I was at the State Department. They do not think of math like a talent. They think of math as a learned skill, like carpentry. Okay, nobody looks at a carpenter and is like, oh man, that guy's just so good at carpentry. I can never do that. You look at him and it's like, wow, that guy must have trained for a long time. That guy must have really practiced that for a long time. How long did it take you to learn how to do that? That's what we say to a carpenter. And that's what I say when I see a great mathematician or someone who is good at math. That's not an innate skill. Nobody is good at math or bad at math. You have some proclivities when you're born, and then you nurture it or you neglect it. Okay? So the Carol Dweck, the psychologist at Stanford, talks about fixed mindset versus growth mindset. Fixed mindset, there are some people that are good at tests. They will always do well at tests. I am that person or I am not that person. All right? That is super corrosive to think that way, and it just won't help you advance in your life or career. And there are other people who they say, hey, you know what? I don't know how to do that test yet, but I'm going to learn, and I can learn, and I can grow and learn whatever is on that test and master it. And that's growth mindset. I am not that way yet, but I can grow and learn it. Okay, so that is what I say about that's what I say about math. Okay, can you all see me? It just said it cut out for a little bit. Are we okay?
Yes.
Okay. All right. Let me just teach you the 8 exponent rules. That's the one thing I'm going to teach you right now. Everything else is going to be in the lesson. Okay? These are the 8 and only 8 exponent rules. I'm going to teach you the hard ones first. There are 5 core exponent rules. X to the A times X to the B. Okay?
Okay.
Does that make sense?
Yes.
Okay. Okay, so when you have 2 to the 3 over 2 squared, that's 2 to the 1. Good?
Good.
All right, here's the third. This is the only one where you get to multiply exponents. X to the A to the B equals X to the AB. So when you have 2 squared to 3, that's 2 to the 6th. Okay?
Okay.
Now you have X to the A times Y to the A equals XY. This is not intuitive, but this happens, and this will show up on the GMAT, I guarantee. 2 squared times 3 squared is 6 squared. Does that make sense? You see how that works? They share an exponent.
Okay.
Okay? Last of the hard ones. X to the A divided by Y to the A is X over Y to the A. Okay?
Okay.
So far, so good?
So far, so good.
X to the 0 is 1. X to the negative 1 is 1 over X to the 1. And X to the 1/2 is the square root of X to the 1. Those are all the exponent rules. All of them. Any questions?
Can you give a moment to write this down?
Mm-hmm.
Thank you.
What is a X to like the 1/3?
That's a great question. What do you think it is?
Cube.
Cube root of X.
That's exactly right. What do you think X, that's X to the 1/3. What do you think X to the 2/3 is?
Cube root of X squared.
That's exactly right, Sarah. Exactly right. Exactly right. Exactly right. If you know these 8 rules, you just boosted your GMAT score by 80 points.
Seriously?
What?
Seriously?
Yeah, you'll see 7 or 8 questions during the GMAT that involve these rules
Oh.
out of the 37 math questions. That's fact. That's true.
Okay. Okay.
Okay?
Okay.
Can we move on? All right. Let's do some problems. Okay. First, place values. Okay. The place value directly to the left of the decimal point is called the ones digit or the units digit. Okay? This is the units digit. Okay, this is the tenths digit, the hundredths, and the thousandths. And this is the tens digit. This is the hundreds digit, and this is the thousands digit. Okay?
Okay.
So when you are rounding, you look at the digit that they ask you about, and then you look directly to the right. And if the digit directly to the right is 4 or lower, you round down. If the digit directly to the right is 5 or higher, you round up. So look at 9,365.47, and the rounding to the nearest units digit is the units digit is 5. The digit directly to the right, is it a 4 or below, or a 5 or higher?
So the rounding up of the 7.
You don't look at that. I said look at the one digit. One digit directly to the right. So the digit directly to the right of 5 is what?
4.
Is that 4 or below, or 5 or higher?
4 or below.
Round down. Okay, that's all there is. All right, so how do you round that to the nearest tenth digit? First of all, what is the tenth digit?
The 10th is 0.7, right?
That's it. And what's the digit directly to the right?
5.
5.
So how do you round this to the nearest tenth digit?
Maybe 4.
Shout it out.
2.8.
That's it. You got it. That's it. Sarah, you're crushing it now. You're absolutely killing it. All right. Go ahead and try this one. I will give you a minute and 20 seconds. Go.
Yes.
Hey, guys. Thank you, Jordan. Thanks, Sarah. Thanks, Alex. Obi, what do you think?
Let me see. I got as far as having the two C's, but in terms of like subtracting them, I couldn't do that, to be honest.
Okay, well, we have C minus C naught. So C is just 0.00465. Okay, is that fair?
Yeah, and for C, what did you get? And for the other C, I got 0.005.
Isn't it 0? What? Nearest thousands?
See, umlaut is the nearest thousandth. That's this. So you're just subtracting this thing from the thing on top. So it's basically 465 minus 500. What are you going to have down there? What are these digits going to be? First of all, is it going to be positive or negative?
Going to be negative.
Going to be negative.
Okay, and what are these digits going to be? 465 minus 500.
35.
What's the answer?
B.
That's it. That's all there is. Okay?
Yeah.
Okay. Any questions on this?
No.
Okay. Let's do a couple more, and then we will. Oh. This is nasty. This is a little nasty. Do you want me to do it, or do you want to whack at it?
Can give it a shot.
All right, I'll give you a shot. I'll give you a shot, Sarah. I'll give you a minute and a half. Go ahead and see what you can do in a minute and a half. Ready, go.
Minutes and a half.
Okay. Take a shot. Okay. Thanks, Alex. Thanks, Obi. Thanks, Sarah. Jordan, what do you think? All right. We got almost every answer. Pretty much covered all of them except for B, so that's good. One of you is correct. So let's find out who got it. All right. What is the 10,000th digit of the decimal K? What's the answer?
I don't know.
Who knows? Nobody knows. The 10,000th digit. That's the tenths. That's the hundredths. That's the thousandths, and that is the 10,000th digit. So I don't know what that is, but the thousandth digit of whatever this thing is times 10 is 4. Oh, so you move that over, like 10x, that means the decimal moves over one spot, and then this is 4. Right. So if you moved that back to where it came from, the 10,000th digit was 4. So that's enough. And then it says the 10th digit First of all, do you understand that? So let's say you had 0.0004. What's the 10,000th digit? Hint. What's the 10,000th digit of this thing?
4.
4. All right. So 10x, 10 times that, you're going to get 0.004. Because the 1000th digit is 4. Right? So that means if you put the decimals back where they came from, you're going to have that. So statement 1 is enough. Got it? Yes?
Yes.
Okay,
Yeah.
so out with B, out with C, out with E, down to A and D. The 10th digit of 1,000 times K is 4. Okay, so we're going to start with point blank, 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 blank. And then 1,000 is 10, 100, 1,000. 4. That's the exact same thing.
Yes.
Great job, Alex. Everybody else, does this make sense? It's a little nasty.
It's confusing.
Any other numbers? Yes, sir?
It is a little bit confusing. I got confused by not really knowing how to solve that. I first thought that that multiplication sign dot meant the decimal. I just got confused with the
Yeah.
way the question was framed.
So a dot in the middle means multiply, and now you know, which is good. It wouldn't make a lot of sense if it said 10.k. So try to make, if you read something and it doesn't make sense, remember that these questions are designed to be solved in 2 minutes or less. It's not like, Sphinx-like riddle that nobody can solve. They're designed to be solved. So think of, how else might they have meant it? Oh, 10 times k. Okay, got it. Yeah. Okay. It's a little nasty, but you can solve it. And now you know how it works. Okay. If you try to do math on this problem, you're going to be in super trouble. You're going to be in a lot of trouble because they only give you one number. This is a logic problem. Okay. As are most GMAT math problems. At their core, they're logic problems. Okay.
Okay.
Very good. I feel the energy seeping from you. So I can feel it. I am getting like stoked. By the end of this class, I am going to be like dancing, probably not on camera, but like when I go black, I am doing like some white man wiggle like you don't even know. You don't even know. Like it is bad. But you guys, I can tell, are a little sleepy time. So that's okay. But here's what we're going to do. I'm going to solve a bunch of problems in a row. I'm going to do it timed, and I'm going to do it in like very energized, heavily modulated. My voice will go up and down. You'll see how I take these problems, and you'll see why I get so excited when I take them. Okay, hopefully that will help you as you launch into your practice between now and Thursday. Is that okay?
Thank you.
All right.
That sounds good.
All right. Check it out. All right. Fractions and decimals. Whenever you're adding fractions or subtracting fractions, just make sure you get a common denominator. On the left-hand side, you got 12. So on the right-hand side, you got 18. So on the left-hand side, you got 9 twelfths plus 8 twelfths. So you got 17 twelfths. And here you got 1 18th minus 9 18ths plus 8 18ths. 1 minus 9 plus 8 is 0. That's just 0/18. 0. Bing, bong, bing, bong, bing, bong. All right, when you multiply straight across. On the top, on the left, this is too hard. So try to reduce. 33/44 is the same thing as 3/4. Okay, both divisible by 11. Okay, so now when you multiply across, oh wait, hold on. 4, 7, 21 halves. And when you divide a fraction by another fraction, just flip the fraction on the bottom, so it becomes 15/4 times 14/25. So dividing by a fraction is the same as multiplying by a reciprocal. Reciprocal is just that fraction flipped on its head. So 25/14 becomes 14/25. Same thing with reducing. We got 3, we got 5, and we got 21/10. That is it. That. Okay, check it out. I'm gonna put myself on the clock here. I'm gonna do this in 30 seconds. Let's put clock up. Stopwatch. You guys see that?
Yep.
All right, here we go. All right, if the numbers 1/3, 5, 6, all that are ordered from greatest to least, all right, let's do that. Well, 1/3. We got 5, 6 over here. We got 7/12 is less than 5/6. We got 2/9 is less than 3/9, and 5/12 is in the middle. What's the difference between the greatest and the least? 5, 6, and 2/9. So that's 18. So 15/18 minus 4/18. Looks like 11/18 to me. Oh.
Wait.
I know. I missed it. Took too long. Couple things. I don't know exactly what 5/12 is right now, but I know it's less than 7/12. I know it's bigger than 1/3. I don't know what 2/9 is right off the bat, but compared to 1/3, I know that 2/9 is smaller than 1/3. 1/3 is 3/9, and you probably heard me say that. What comes out of my mouth is everything I'm thinking. So, which is a problem in my relationship, but a good thing on teaching the GMAT. So that's a little too close to home. But 5, 6, that's a pretty big number. It's almost 1. 2/9 is a pretty small number, and there's nothing smaller than 2/9. 1/3, no, 1/3 is not smaller than 2/9. So I just did 5, 6 minus 2/9. And I knew that the common denominator between 6 and 9 was 18. Make sense? What are your questions?
So when you do problems like this, you don't waste time getting all the common factors. You're just kind of doing it in relation to the number right next to it.
Mm-hmm.
Okay.
Here's why. You know, I don't need to know what 5/12 is in 18ths or 36, because it's like 5/12 is like it's almost a half. That's not going to be the biggest or the smallest. So
Right.
Who cares? Why am I going to do extra work?
Yeah.
I'll make yourself do extra work. Okay? Let's do another one. Was that fun?
No.
No.
It was awesome.
Yeah. What?
Fun.
All right, let's do another one. Okay, this is gonna take a minute. I think maybe I'll give myself a minute and 10, but let's put up the clock. All right. 0 is less than R, which is less than S, which is less than 1. What is greater than 1? I don't know. Who knows? But I know that R is less than S, which is less than 1. So maybe R is like a fourth and S is a half. Maybe R is a half and S is 3/4. I don't know. Let's keep it easy. Like those are pretty simple numbers, right? Right?
Yes.
Okay.
All right. So is R times S greater than 1? Does that have to be greater than 1? Well, 1/4 times 1/2 isn't greater than 1, right?
No.
So that doesn't have to be right. R plus S, is 1/4 plus 1/2 greater than 1?
Let's see.
No.
No, it's not. So that doesn't have to be true either. I'm done.
Really?
I mean, you can do the third one.
3, huh?
Well, it's the only one left. 3 has to be true. But 3/4 divided by 1/2. Yeah, that'll work out. 3/4 times 2.
It'll be 1.5.
Yeah, or 1/4. Sorry, yeah. Sorry, 1/2 divided by 1/4. So 1/2 times 4.
Yeah.
That works. Right?
Right.
Just the hardest part of that. In fact, probably more than half the time I took on that was just setting it up and coming up with numbers. How many letters did I end up using in my math? No letters.
Zero.
No letters. Letters don't help. There are enough letters in this problem. I do not want more letters. Some people are like, but what about if you integrate z and then you take the derivative of zeta? And I'm like, dude, you can just go back in the hole. The test is a logic test. The test is not an algebra test. It's not a test of how well you can use variables or letters. You get no partial credit. Just pick some easy numbers to work with. Find out the answer to the question that they're asking. Okay?
Do you always try to do substitution when there's when there's a question kind of like this? Substitution is always the best route to go.
There's so many letters. You know, we talked about that golf metaphor, just like pulling out the right club for each you know, each kind of situation. This problem has no numbers in it, and they're asking me for a concrete number, which these has to be greater than 1. Oh my God, I have no idea. I need an example. If I don't have an example,
What if you substituted in 0 for one of them for S?
it says that they're both greater than 0.
Oh yeah.
So you have to pay attention to what they don't give you that much information in the words before the question, but the information they give you have to listen to. Those are ironclad rules, and if you break it, if you try to test a negative number or try to test a 0, that's not allowed. They told you that wasn't allowed. So make sure you read the statements, because I think all of you at some point today, you missed the words prime number, or you missed the word integer, or you missed, that is so common. Almost everybody does it. I do it. I do it a lot. I just have learned to slow myself down and read that stuff before the question mark so slowly. Because there are places where you can rush, but reading the question is not a place you should rush. You should actually slow yourself down. Slow yourself down for that part.
Well, we actually read it, but later on we forgot about it.
Right.
Yeah.
How about decimals? You would recommend always use fractions over decimals in situations like this?
You know what? Use whatever's easiest for you.
But
I'll tell you what.
They're easier to to solve.
Mm-hmm. Yeah, no. For me, fractions in this case were super easy.
More complex, picking 0.5.
Mm-hmm.
If you have to multiply, it's gonna be
different people.
Time consuming.
Mm-hmm. I think that the key is, even with the hidden thing that I did here, which I have mentioned several times already in this class, and I'll mention again in other classes. Even within my very constrained limits, both of them had to be between 0 and 1, and S had to be bigger than R. I still picked different kinds of numbers. Yeah, that sound means that's an insight that one of you had. That's what do that again. Do it every time you have an insight. Whoever did that, I want that sound. So R and S in the first case are pretty small, like lower than a half, and R and S in the second case are pretty big, bigger than a half. And I did that on purpose. Do not pick 0.1 and 0.2 and 0.2 and 0.3.
Okay.
You see that? If they give you the ranges between 0 and 1, make 2 of them pretty high and 2 of them pretty low. And then you'll get different answers. And you'll be in pretty good shape. Don't pick 0.1 and 0.2 and 0.2 and 0.3, or like 1/10 and 1/9. Don't do that. Pick easy to work with numbers that are different kinds of numbers. First set was pretty low, second set pretty high. Done. Make sense?
Makes sense.
I hope you're getting a sense that like studying for the GMAT, first of all, is a lot of fun, I think. And secondly, the essence of it is like trying to figure out these little logic puzzles. It's a little bit math fundamentals. Maybe you need to study more fractions, a little more exponents. It's okay. But it's not like you just have to trudge through. If I just learn my exponent rules, then I'll magically be in the 700s. That's not how it goes. It's practicing logic puzzle after logic puzzle and getting exposure to the different ways that the GMAT tries to trick you and outsmarting it. Okay?
Okay.
All right. So let's finish up this lesson here. Let's erase. Okay. You can break apart fractions up top, but not on the bottom. So 7 halves can be 5 halves plus 2 halves, but you cannot break apart the denominator. This is not allowed. You can always break apart the numerator. All right. This one is nasty. I will do it for you very quickly. But basically, if AB does not equal 0, is 1 over A minus 1 over B 20? I don't know. Statement 1, maybe B equals 3A. All right, so maybe A, how do we get 1 over something minus 1 over something equal to 20? God, wouldn't it be great if this said 30 minus 10? That would be easy. Well, maybe A is 1/30th and B is 1/10th. And then it's just 30 minus 10. So statement 1 says, well, if B equals 3A, is that statement true? Maybe it is. But maybe B is 6 and A is 2. And then it's not. So statement number 1, not enough. Statement number 2 says B minus A equals 20AB. Huh, that's interesting. That looks really, really similar to this, doesn't it?
Yes.
You know what? You know what I'm going to do? I'm going to divide everything by AB just to see what happens. So if I divide everything by AB, on the right-hand side I have 20, and on the left-hand side I have B over AB minus A over AB. Well, the B's cancel here, and the A's cancel here. And so now I have 1 over A minus 1 over B equals 20. Guess what? Statement 2 is the exact equation that they're looking for. So it's like, hey, I have a question for you. Is Toblerone your favorite dessert? And then you say, my favorite dessert is Toblerone. By the way, it's not true. But if it were, if you said that, you'd be like, okay, I have my answer. Statement 2 is just saying, it's like, is 1 over a minus 1 over b equal to 20? And statement 2 is saying 1 over a minus 1 over b is equal to 20. And guess what? Amazingly, that's enough. The answer is B. That's just annoying, and I think you have to be that kind of arithmetic. In that statement number 2, you have to say, gosh, that equation looks very similar to the equation that they gave me up top. I wonder if there's a way I can move things around and get something that would be useful. Do that, try to play around with it. Play around in that particular way, you'll get the answer. Yep.
For statement number 1, were you able to prove it right?
Yeah.
How?
1 over 1/30th minus 1 over 1/10 is equal to 20. And
So,
B, 1/10 is 3 times 1/30th.
So wouldn't you place the 1/10 on the left side of the equation? Right?
Yeah, 1/10 is 3 times 1/30th.
Oh, I get it now. You simplify after you multiply. Oh my god. Okay. And are you able to prove it wrong? Okay, never mind.
Yeah, because if B is 6 and then A is 2, then B is 3 times 2, so that works. But 1 over 1/2 minus 1/6 is not 20.
Okay.
Cool.
Yes.
That's tough. That statement number 1 is nasty, but the way I did it is the way to solve it quickly. Want me to do one more, and then I can end with a little like a rousing call to arms?
Yeah, will you do one more?
Yeah, let's do it. Okay, fractions and decimals. You need to know how to convert not every fraction in the world to decimals, but basically 1/2 through 1/11. So basically you need to know halves, thirds, fourths, fifths, sixths, sevenths, eighths, ninths, tenths, and 11ths. You need to know those to decimals. A lot of these you probably already know. 0.5, this probably looks similar to, you probably already know those, but you need to know all the other ones too. So I don't ask you to memorize much, but these you got to memorize. Once you know what 1/8 is, you can get 5/8. But helps to know 5/8 too, but you have to know what 1/8 is. 5/8 is just 4/8, which is a half plus 1/8. Right? Okay. An increase in the numerator increases the value of a fraction. So like 5/8 is bigger than 4/8. That makes sense. An increase in the denominator decreases the value of a fraction. So you'd rather have half a pizza than a third of the pizza, right? Unless you're on a diet. And then maybe not. All right. Okay. So use an easy to calculate benchmark rather than the numbers themselves. So 20/29 is a little bigger than 2/3, and 13/21 is a little smaller than 2/3. So that saves a lot of time. Got it? All right. Okay. This one I hate, actually. This one is, I've never seen anything like it. The only time I've ever seen this is this exact problem. So I'm going to do a different problem as the final problem. So these are 4 of the exponent rules. I've shown you the other 4. This is a great one to finish on. This is a great one. So I'm going to do this in 30 seconds. On top, we have 6 to the third times 7 to the fourth times 2 to the sixth. Well, 6 to the third can be broken up into prime numbers, and you get 2 to the third times 3 to the third. So now on top, you get 2 to the third times 2 to the sixth times 3 to the third times 7 to the fourth. Cool?
Yes.
Oh, but I bet you can combine these. So on top, you get 2 to the ninth times 3 to the third times 7 to the fourth. Cool? On the bottom, you have 168. Well, I don't know what 168 is, but I bet it's 2 times 84, 2 times 42, 2 times 21, 3 times 7. So 168 is actually 2 cubed times 3 times 7. All that to the third. So on the bottom, you have 2 to the ninth times 3 to the third times 7 to the third. What are you left with?
7.
That's it. All done. Isn't that amazing? That's like a miracle. It's amazing. All right, here's what I'm going to say. We will pick up with slide 20 on Quant lesson 2 next time. We will finish out this Quant lesson, and then we'll do verbal on Thursday. Here's what I want to say. Everything we did tonight, some lessons are going to feel long. Some lessons are going to feel are going to drag a little bit. When that happens, I will sense it, and we can pick up the pace. I can do the problems. I can show you some new tricks. I will dance only from the waist up, but you know, I will do whatever it takes to keep you entertained and engaged and having fun. Studying for the GMAT is work, you know, for a lot of people. Not for me, but you know, for most people, it's not something they would choose to do in their free time. I get it, but it's not like you know, it shouldn't be like extracting, you know, parts of your soul. It should be like, you know, playing with numbers, figuring out a puzzle, and everybody can do this. I have never. That's not true. I've met some people who. I very rarely meet people who are incapable of learning the basic tools to succeed on the GMAT. And just from today, I can already tell you, all 4 of you are perfectly capable of getting very high scores on the GMAT. You got to put in the work, come to class, do the homework, but send me questions by email in between classes, and I will try to get back to you as soon as I can, usually within 24 hours. Come to office hours. You get to see me without the tie. Very exciting. And ask whatever questions you want. I'm here for you not just as a teacher. I am a coach. I am a resource. I am, you know, a guide to this very important part of your life. And if you take my class, you're going to learn what you need to learn to get the score you want. Okay? It's so fun to meet you guys. It's so fun to be with you. If you like the course, tell some friends. We're always looking for more Ready4 students. And definitely give the feedback to Julie and the gang up at Ready4 headquarters. And again, I am here for you by email anytime. You can always send me a note at maltzer@gmail.com. But for now, it is 8:01 p.m. here on the Pacific coast, and it is past 11 out east. I'm going to bid you a good night, and I will see you guys Thursday evening, 8 p.m. Eastern, 5 p.m. Pacific.
Can I ask a quick question before you sign off?
Yeah, go ahead.
When is the office hours?
Office hours is Saturday. I think it should be Saturday morning at either 10 a.m. Eastern or 11 a.m. Eastern. If it has not been sent out, Julie will send it out between now and the next class. Okay? And if you can't make that office hour, we will schedule an office hour that works for you, at least one. If if I notice that people aren't showing up to office hour.
Okay.
Okay.
Thank you.
Any other questions before we sign off?
Next class is verbal or quant?
Next class is verbal. We'll finish up this lesson. We'll finish up Quant 2, but then we'll do verbal.
All right.
All right. Thanks.
All right. Good night, everybody.
Thanks, Eric.
Thank you.
See you
Thank you.
Thursday. All right. Bye-bye.
Bye.